Lesson 28, Scientific Notation for Very Large Numbers. First up, what is scientific notation? Definition is a method to write very large or very small numbers with many zeros. And our method is going to be writing a decimal number, and so the decimal number, known as a coefficient, needs to be between 1 and 9. So the decimal point, the number to the left of the decimal point has to be a non-zero, so it has to be at least a 1 times a power of 10. And so if it was like 4.3 times 10 to the 5th power, this 5 tells you I need to move this decimal point 5 places to the right. And that would be in standard form if I were to write the actual number, what 4.3 times 10 to the 5th would be. And so we use this for really, really large numbers because it's easier to read than trying to figure out is this in the billions, the trillions, or even more than that. So let's take a look at some examples. The Earth's average distance from the sun is 93 million miles. Write 93 million in scientific notation. So I know I need to have only one digit that's not a zero to the left of the decimal points. That's going to be 9.3. And right now the decimal point is right here. So I have to move it 1, 2, 3, 4, 5, 6, 7. So since I moved it 7 places, this is going to be times 10 to the 7th power. And it's a positive 7 because in standard form, my number is greater than 1. If it was less than 1, then it'd be to the negative 7. Next example, write 2.5 times 10 to the 6th with digits. So I'm going to write that in scientific notation, or actually the first part with 2.5. So 2.5, and since it says multiply it times 10 to the 6th, I need to move the decimal point 6 places to the right. So 1, 2, 3, 4, 5, 6. And wherever I see these dips, I'm going to put zeros in. And so now if I were to write my answer, I would have 2,500,000. That would be my number with digits. Next one, 365,000. I need to write that in scientific notation. So it'd be 3.65. So I use all my digits except for zeros at the end. And this is going to be times 10. And I moved it 1, 2, 3, 4, 5 places. So 10 to the 5th. Next one would be 2.95 times 10. And I moved it 1, 2, 3, 4, 5, 6, 7, 8. So 10 to the 8th power. And 70,500, this would be 7.05. That time I had to keep the 0 because this 0 is in the middle of my two non-zero numbers. Moved it 1, 2, 3, 4. So times 10 to the 4th. And then 25 million. If it's written like this, then maybe you just write it. I know it's going to be 2.5 times 10. How many times did I move it? Let's write out the full number. There's 25 million, so 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th. A couple other examples. When Brigitte finished the 1,500 meter run, she announced that she had run 1.5 times 10 to the 6th millimeters. Write that number A in scientific notation and then B in standard form. So first in scientific notation, 1.5 times 10 to the 6th millimeters. And then in standard form, I know I have the 15, and they moved it 6 times. So 1, 2, 3, 4, 5, 6. fill these with zeros. And then if I were to put my commas in here, it would be 1,500,000 millimeters. And then writing everything else in standard form when it's already in scientific notation. 2.0 times 10 to the fifth. I have 1/8, so I moved it 5 places. So 1, 2, 3, 4, 5. Fill these with zeros. So I would have 200,000. Here we got 7.5 times 10 to the 8th. So I'm going to write my 75, move to 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. Fill these with zeros. Put my commas in. So we are at 750 million. Next one, 1.609. And then I moved it 3 places. So 1, 2, 3. So my answer would be 1,609. And then 3.05. Moved it 4 places. So 1, 2, 3, 4. Fill these with zeros. We're at 30,500. So that is our lesson on scientific notation used to write really, really big numbers. Or you can write really, really small numbers, but today was just learning how to write in scientific notation with really large numbers.